Welcome everybody, SUSE QE Tools Workshop, today the 11th of June 2021. Today's topic will be Intro to os-autoinst development. And what I would like to do is demo how one could investigate certain thing and test a small fix, assuming that you might want to help contributing there and not start with a fully new feature, but maybe a smaller thing. So for that, of course, we need the source code of os-autoinst. Os-autoinst is the main and or currently only backend that is actively supported and used within OpenQA. So os-autoinst is the component that actually runs the individual tests. And that is done by executing one executable script, which is called iso2video. So this was actually existing already with that name when Bernhard Wiedemann originally created that project, even before OpenQA was built on top as a way to nicely show results from iso2video runs. But still, and this is something that I can recommend to power users, that can also be called manually on its own. And if you want to have a general introduction how to do that, there's the README file, which is the main documentation for os-autoinst itself when trying to run that independently of OpenQA. So for example, I just want to give a small glimpse into how that is structured. There's getting started. And you can, for example, if you have an OpenSUSE Linux distribution, you can install the os-autoinst package and then just call iso2video with either command line test parameters or a file vars.json, which I can show you how it will look like. If you want to run it from containers, then an example is shown here using Podman. So with Podman, you can run this container image for which we call iso2video, which is provided on the OpenSUSE container registry. There are different variants. That one is the variant that relies on KVM virtualization acceleration. If you have that in your environment, then this is what I suggest. If, for example, you want to run it on x86-64 with no KVM support, then you can use the QEMU x86-64 variant. Here we see already we can pass parameters directly on the command line of iso2video or that container run. And also what is done here is if you have a test distribution, like for example os-autoinst distri OpenSUSE, the main test distribution that is used for OpenSUSE as well as SUSE Linux Enterprise Linux distribution tests, then you can provide that directory in that container and then it will be able to run the tests as defined in there. iso2video can take test command line parameters where you can use lowercase or uppercase for parameters. So this is just showing an example of how that could look like for defining a test distribution, directory of where the actual test files could be found, and assets like an ISO file that you want to have access to in your tests, and then boot the test from that ISO and conduct tests. As the alternative to command line parameters or complementary, and we can have a JSON file which includes the same test variables like distri and case as shown in example above. Are there any questions or note regarding running ISO2 video from os-autoinst manually so far?
I have a question.
Sure.
So from my side, I used to run sometimes jobs with vars.json, and for me it's always not like a challenge. I can do it, but what I'm usually doing, I'm taking vars.json from some job and then start clean up from the not necessary variables to have like a like smallest amount which needs to job to be run. And
Right.
it would be nice to have like the list of variables, minimal set of variables which is needed to be able to run the job with vars.json.
Yeah. Very good point. So just to show an example of what one can do, or what Anton mentioned that he is doing, take, for example, this job, or maybe a failing one that you want to investigate. You can go to logs and assets, and there's the vars.json file, and you can download that file and execute it. A side note is that recently we invested some effort to make this vars.json file, as it comes from existing OpenQA instances, directly usable. Previously, you had to delete some variables and path in particular, something like cache directory and such. And nowadays, that should not be necessary, because in before it was like having hard-coded, for example, for ISO, it was having hard-coded absolute paths that are relevant for one specific worker instance, like var lib openqa pool number 42 / and then the name of the ISO file. And of course, if you would run ISO2 video locally based on a vars.json file, if you wouldn't have that very same worker instance directory, then you would need to delete that path or override it and change it. Now that's not necessary anymore. If you just have the ISO file like in the current directory, then it immediately works without any changes. Okay. For the minimum parameters that you need, this is a good example, which is actually already more than just the minimum. The bare minimum, what is always required, is case dir. But this is the only variable that you would need, and maybe not more to start. Okay, so you can say ISO to video, or you can try it out, and I would like to try it out in a demo, and then we see what is actually necessary. Okay.
I assume at least these three also needs to be specified. No?
Actually, no. This tree is something that is only necessary in the scope of OpenQA, but ISO video doesn't actually need it. Of course, if your tests read that, like if your test code does something like, if this tree is this, then do this, otherwise do that, then of course you need to make a choice, but this is like an additional requirement that comes from your specific test implementation.
So once again, you're saying that current state of the art, that I can take vars.json and use it to trigger the job, and it will not fail with all these cases which you just described, with some hard-coded paths or some hardware is used like in a way that it will not run other than in some specific worker.
Well, I can't.
It's working out of the box.
Yeah. That's how it's designed. Yes, that's how it should be if you have all the prerequisites. Of course, that can have additional requirements. If you have a backend which you can't support, like not QEMU, but let's say S390 or bare metal, then of course you would need to have this variable set accordingly locally, right?
Nice. Thank you.
Right. Okay. So how to run test cases. So assuming that you want to run ISO2 video as we described with an existing test distribution, then we have two examples shown here. One would be for the OpenSUSE test, where the test distribution is called os-autoinst OpenSUSE. And the second one is the OpenQA self-test, the os-autoinst distri OpenQA. So what we do here is an example. We clone. Oh, I see a problem here because that example is missing the clone command. So here it says git clone, and now we have an error in our documentation. So it should say git clone this distribution to that path, and then you can create temporary directory, create a vars JSON file with this path to the test distribution, which we just checked out, or the other, and then you can run iso-video. Running iso-video will run the test, and it will show the log output in the current terminal where you call iso-video. If you want to interact with the SUT interactively, or if you would just want to take a look, if you want to do like what the OpenQA live viewer is providing, which is a VNC-based screen capture of the SUT, then you can connect with VNC viewer to the local instance. Yeah, so develop test modules, like if you want to do the tests, and this is actually a part which we more extensively cover on the OpenQA documentation. This is why we relate there. And now the core part for the meeting today is how to contribute to os-autoinst itself. And this is what is described here with... Yep, go on.
Can I have a question? You said that the logs are available in the terminal.
Yep.
But what logs is it, that os-autoinst log or the serial terminal log?
Yeah, the os-autoinst log. The serial terminal log will be stored in a file, just as you would be able to download that file in OpenQA. So the file will be in the current directory then where the tests had been executed.
Okay, so I can tail the file, for example.
You can tail the file in the second terminal, for example. Yes, you can.
Yes, thank you.
Okay. Build instructions. So if you want to contribute to os-autoinst on OpenSUSE, you can install the package os-autoinst devel, which pulls all dependencies. On other systems, you can read out the dependencies YAML file, and from there you can install packages. And I will just show you afterwards an example here in a Google Cloud Shell, which I use for demonstration purposes, where I installed the dependencies directly by taking a look into the dependency files and reading out the dependencies from there. And an alternative, of course, can always be to use a container environment where I could run from Debian, I could run an OpenSUSE container, and within the OpenSUSE container, I can directly use the development package. And then conducting the build is as simple as calling make. We use cmake, so if you know cmake, then of course you can also create a build directory and call cmake yourself and tweak it. And to run all the tests, you run make check, which includes style checks, static checks, as well as dynamic runtime checks. And the dynamic runtime tests and checks are, you can also call individual make test Perl suite. Or if you select this individual one, then you can parameterize that with the test parameter on make. You can give additional proof arguments, or you can call proof manually. If you want to collect coverage, you call make coverage. Now that was pretty quick. I would like to show that as well. I just wanted to give you an overview of what is possible, and now I would like to do that myself. So what I have prepared is an environment where I basically called, let's say, the equivalent of clone command, I can do this. And that shouldn't take that long because that repo isn't that big. I go into the directory and then I can take a look into the dependencies YAML file. Let's see, can I open that? There's a workspace here. So I have the working copy, the workspace, and what I see now is the checkout of the os-autoinst directory. There we have the central make file, we have CMake list, and we have the dependencies YAML file, which shows all the dependencies. If you want to install from the OpenSUSE package, then again, that's not a problem because you can just call zipper in os-autoinst devel and you get all the development packages. Here on Debian, what I did is I used the corresponding Debian package names and Perl dependencies which are not provided in Debian. Oh, sorry, I think in Google Cloud is actually Ubuntu. Yeah, not that much of a difference. So I was using then cpan to install the additional dependencies. And this is why I'm needs that additional path. And then I should be able to, sorry, it's a bit slow here.
May I ask a question meanwhile?
Go ahead.
So using dependencies YAML, is it like some common approach somewhere? I don't know, or it's
no, actually we have not found a better approach. That it's always a problem with dependency management in multi-language projects. Okay, so for a pure Perl project, you would likely use just a cpan file, and here you have Perl packages mentioned. But we were looking for an approach how we can structure dependencies in a language agnostic format, and then we generate from that dependencies YAML, we generate the cpan file and we generate the spec file, which is used for building RPM packages. And we also generate a list in a Docker file that is used to install dependencies, for example, formerly in a Debian container.
And this logic for generation, all this word, it's like it's in make.
So this was mostly, if not completely, done by Tina Müller. So Tina, thanks for that. And the logic for that is provided. I think, yeah, it's called update steps, and that is included from an external repository. So it's like it's separate Git repository, which is pulled in here. So we use that for os-autoinst and we use it for OpenQA. Maybe for another project, I'm not sure, but in theory, it can be used for other projects as well.
Looks interesting. Thanks.
Right. Okay. So let me try something. What I'm doing is I'm creating a build directory, and then I'm calling CMake on the main directory, and it says build. Oops. not Punjabi, use make here, fine. I'm building the final target, which is called symlinks. And what we do here is we build executable. So we do have some C code or C++ code actually in here, for example, for the video encoder and the actual screen comparison against the needles. That is a C library, and some supporting tools like video encoder, debug viewer, also sound to PNG, where sound that is recorded is transformed into a visual representation, which is then used for comparison. If you're interested about this needle matching algorithm that is mostly relying on OpenCV with a tiny CV library, where that is then included as a C object files that are provided as Perl modules, so that from Perl code then that library can be accessed. Okay, now we have built. That means we have all dependencies to run the complete test suite, including complete ISO2Video. So what we can do is we can call ISO2Video. And if we do that, then it's asking us for that one single hard requirement, which is case-dir. Okay, so we need a test distribution. If I would like to try it out here, I'm just creating a new directory so that we have a clean directory where right now there's nothing in there, but if we want to call ISO2Video and it records log files or the video, then it will be stored in that directory. So ISO2Video and now case-dir. And if we want to try it out, then we can use os-autoinst dist3 OpenSUSE, we can use os-autoinst dist3 OpenQA, or what I'm providing here is the test distribution, which we have within the working copy of os-autoinst itself, which is starting a tiny core ISO file and then seeing that we end up in a shell. So let's see if we can run that. Right. So what we see is that it finds the tests from there. And then here we already had that problem the last time when I was looking into running the test from this environment, that we have a problem with the the Python support, which I can most likely easily patch out. I think the last time you wanted to see me using more the visual editor and not the not Vim within the toner. Okay. Now that's being a bit slow. I need to give a minute for the browser to catch up. Sorry about that. Where was it? Main PM. I think we don't need that. So you see how it progresses at least a bit further. So what we can see here is that now it's reading all the test module files from the local test distribution. And then it goes into the backend, which by default is QEMU. And from the backend, then it starts KVM. And maybe I'm missing some permissions here. Yeah, we can see here that failed to initialize KVM, so that won't work, but there is a perimeter which we could ask to run without KVM. Yeah, Anton, question?
Can you please comment on these log entries at the beginning? When I first time have seen them, they are like scared me about like blocking seek term, blocking. There's like at the beginning you're
I know.
exploring, and yeah, and they like you are looking at this and you think that something going wrong.
I know that's always a problem with a challenge with log files, how to raise them that they are informative but not making you want to do something when you don't need to do something. Yeah, you're right.
But yeah, but just can you explain what's happening there? What is trying to say?
I think Marius can be the expert. Marius, can you explain this signal blocker concept of blocking sigchild and sigterm? What's the purpose of these?
Yes, as you can see there, can you hear me?
Yep, go on.
Okay, good. Just because I haven't said anything before. So as you can see, these are debug messages. So you can already assume if you have an error or something, these will likely not tell you something about the actual error because, yeah, they are just debug messages. And the signal blocking is used because we had crashes of the backend if it receives a signal like sigterm. And the problem is we have, as Oliver mentioned before, a backend library called tinycv.so, and it spawns a lot of threads. And usually in a Perl application, we only have the Perl thread, but we here have also these other threads spawned by tinycv. And the problem is if you now send a signal to the process, an arbitrary thread may receive the signal, but in order to not crash, actually the Perl runtime needs to receive it because the Perl runtime does the signal handling. So here we basically block, yeah, it's a little bit complicated to avoid having the signals on the wrong threads. But it's actually possible using some system commands, and yeah, basically you say before you spawn all these other threads that you don't want the signals to be received here. And then you, if you spawn them, you say, okay, now I'm free again to receive signals. So that's why you have the blocking line. And then again, after the threads have been spawned, you have the unblocking line. And we have multiple processes in our architecture. So we, of course, need to do it for all the processes which load tinycv.so. And this output is an interleaved output of all processes. So you see the log line multiple times.
Yeah, but I also realized the same, that it can look a bit verbose or scary, especially because, of course, by convention you write the signal names in uppercase. So Marius, I noted that down as a comment. Maybe we can just rephrase the messages a bit and find a better wording. Okay.
Okay, not exactly sure what you mean by that.
I mean, just finding different words to describe it. Okay, so I tried an option now to run that without KVM because, you know, I'm now in a cloud environment where that doesn't work, but doesn't matter. As the next thing, I would like to show how to run the unit and integration tests. Before that, I would like to give the opportunity to you for any further questions or comments regarding running ISO to video manually.
I actually have a comment about the coloring. I recently implemented having the colored output also in OpenQA, but now we also see it here. And the problem, or let's just say, it's not nice how the coloring is done actually. It's very inconsistent.
In what way?
If you go up a little bit, maybe you see an instance. Okay, now here you don't see it, but sometimes messages are really colored inconsistently.
Yeah, so for example, there's this D message line, and that isn't like this. This is like passing through without any coloring and such. Okay.
For instance,
right. I mean, by default, we have most of it is in gray.
Or here you have even an info line which is colored completely different to the info lines we have elsewhere. I mean, this command server info line.
Actually, no, because that is with this 3 colons. It's a different concept. It's not just info, but additionally telling you about the back-end state in case of important state changes. And here it says like QEMU terminated before we could establish a connection. That means we then need to take a look into QEMU debug output. It's just a bit unfortunate that these, which are the most important critical error descriptions, are then hidden as debug. But this is a problem because, you know, we just get it from QEMU in the same way as the debug output, so we can't easily separate that unless we would pass the message and say like, yeah, this looks like an error, you know.
Yes, that's of course not so easy.
Are there further comments or questions regarding running ISO to video locally? Seems like not. Then I will try to show you. If the environment is completely set up, then we can run one or multiple of these unit tests. So for example, some of you already have experience when they are extending code in a certain backend, then partially already test code exists for these backends. And if it doesn't exist yet, then I will most likely ask you in a pull request, like, can you please also extend the test code accordingly? I have to try if the following works if I just call approve manually, which would work something like this. I say proof, I give it one additional necessary parameter as mentioned in the documentation to include the current directory to find the local Perl modules and then execute that one single test. And as we can see, within 1 second, all tests are successful. So this already works. If we want to exercise through test-driven development, and let's say you want to change functionality or add new functionality, then what you can do is extend the test here accordingly, and then run it and then change the source code. Questions for that? May I ask who has already tried to run these tests and maybe you had success or maybe you did not have success? Show of hands, mention in the chat, speak up. Your feedback is appreciated. Yeah. So I haven't tried the unit test. Questions about the structuring of tests? Okay, if if, for example, let's say we want to create a new a new test module for something that doesn't exist yet. Let's see, for example, S390X. Okay. For S390X, I think we don't yet have that in the test code. No, we don't. So what I will do, I will copy that to a new file. No, not Vim. Open that here. And now replace all that. Can I replace all? Yes. And now I will delete what I don't need yet, or I'm not using yet. I will keep, oops, sorry. What I will keep the test most, of course, because I want to run the test. I would like to keep this use lib so that we can find the external test library, which provides us timeouts on the level of individual tests. And that's 5 seconds timeout. So as you have seen in before, the IPMI backend test takes like 1 second to execute. And here we are being, let's say, we have a bit more conservative limit, but still on the low side, just some seconds that we low. We also use test warnings so that whenever there would be any Perl warning showing up in the test, use that noisy right. Providing an awful amount of noise. Struggle here to find the mute button. Leon, thank you. Okay. So, you guys still with me?
Yes.
Good, thank you. Okay, I will just keep one single line for a start. I will use the backend and I will then call done testing. And I will just call that single file. And then it says all tests successful. And it says that there is actually one test. The one test that is included is that there are no warnings. Okay? Now, the next thing that we can do is to say, well, what functions do I want to test? And I'm starting with the most basic and most simple one. I'm just going to instantiate the objects where the method is new. So I'm using syntax of test most, which is very similar to test more. It's like just providing some convenience libraries on top. We can say, okay, backend S390X new, and then can instantiate backend. Save and run, and then it says test fails. Why? Because can't locate. Wait, what did I do wrong? You need to do it like this. Is it saved? Yeah, it is. Yeah, right. I need to instantiate a variable, right? Correct, like this? Let's see. Yes, works. And now the next error is could not retrieve required variable worker host main. Who has a hint? What we need to do is these variables, these are the same test variables that you know from test code, where you would use something like setvar and getvar. But now here, I don't want to use the public test API within internal code. So what I'm going to do is I access the internal object, which is called BMW QEMU vars worker host name, and then I set something here like localhost. And with that, the test can pass because we have provided all the dependencies. What would be the next thing to test? Of course, we don't have an S390 mainframe available here, but what we can do is we can try to mock certain things. So for example, I can call check socket. And this is really just trying to play around and then see where I can go, make a test fail, and then see what I need to do to make the test work. So I would call can call check socket fails, which is obvious because check socket does not return a true value. Phoenix, I will come to your question in a second. So we can just say that, yeah, this returns, I think it auto saves. This returns a false value by default. So we can make that the very trivial test for correct operation, and then we say, okay, not check socket, right? And we can go from there. Now, next question. What does BMW QEMU stand for? So this is, let's say, the heritage which so far we preserved, that BMW QEMU there stands for Bernhard Wiedemann QEMU. It's a very misleading name because nowadays, I mean, the original primary and single backend was QEMU, but nowadays we have the folder of backend, meaning everything that is QEMU specific is within backend QEMU, and BMW QEMU is kind of like a collection of 2 or 3 classes together, and let's say I'm in the process. This is like one of my most low priority tasks over the course of years, that I'm extracting from that file things which make sense. For example, there's one part which hides in there, which is logging. Okay, because that one defines methods like diag and mod start and info1 and result calls. But it also includes this main object of all the test variables, which is in here, and some other smaller helper files like serialize state, result dir, and such. Update line number, current test, which is also partially for logging and partially some kind of generic interface for backend management. But yeah, the plan is to make that a bit more clear from the name. Okay. So further notes, questions. What are your own experiences with that? Do you think how, and I would be interested in one specific point. How much do you think it is feasible to have tests for backend code, which is very much dependent on, well, specific hardware behavior?
I can generally comment about tests in OpenQA. That is always struggle for me, and yeah, I always spending a lot of time on just making them work, and yet fix them is also problematic. And my last experience with the parser, I was a little bit shocked with this file with 1,000 lines.
Was that in
I don't know.
os-autoinst or OpenQA?
No, it was in OpenQA.
But
yeah. I somehow, I don't know, I think it's similar, right? Or
yes,
exactly? Yeah, and I don't know. My opinion is that exactly this is probably too much. I don't know, too complicated for the test. But I don't know.
Yes, you're likely right. There are some. The one example that you mentioned is also one of the tests which I personally don't understand at all. Yeah. Okay. Other experiences with the self-test of OpenQA or os-autoinst, or my question regarding feasibility for simulating hardware? Marius, if I may put you on the spot, because I know that you do have also experiences with this back-end test files. What do you think? What's your feeling?
Did you mention that there's the mock module, Perl module for?
Yes.
Okay.
Okay. So no, yeah, I didn't mention it. I just deleted it. So yeah, that's a good point. So yeah, we have that in backend RPMI. Go on.
Yeah, it's very useful. We also use it in tests in OpenQA. And it's exactly where his cursor is right now, test mock module. That allows you to basically say, okay, this function within this package should now be changed to something else. Mock object is similar, but usually mock module is the more interesting one. And yeah, if you want an example, you just see it in line 25. Here we say, okay, we are creating a new, here we just say, okay, the package backend IPMI should be mocked, and then we redefine certain functions there. So in the case of the other backend test, which Oliver just started, we would likely use the same approach for not actually having the SSH connection and such.
Right, exactly. And this is also the only feasible way how to keep a test runtime within the range of 1 second, because we test the logic which is within that specific backend without relying on external dependencies like actual hardware.
And I would yeah, just one note. What I actually always do before I adjust a test, I run the test before I do anything just to verify whether it actually runs in my environment, and then I do some changes because it's not so hard to get something wrong, and it's good to know that it's just not working as is.
Right. Thank you. So this is this can also be like a very short introduction into test-driven development. Very first step is run the tests without changing anything and show that they can pass when your development environment is properly set up.
I also have one further note. Can you go to the tab on the right where you have GitHub?
Yep.
Genau. Go a little bit down. There's a link within the README for the architecture, and that's actually quite interesting because as soon as you start developing os-autoinst yourself, I think you've gone too far.
Yeah.
No, you're right. As soon as you start to develop os-autoinst yourself, you will notice that I'm setting a variable here and I can't read the value there. And the problem is that these places are likely just running in different processes. I'm not going through the list here, of course, but that's basically the tree. And when I created this documentation, I really just looked at any process manager which shows the tree and wrote the documentation according what I observed. So that's also sometimes helpful just to see, okay, how does the process tree look like? How do the command lines look like? And here I also mentioned which files belong to which process. Of course, it's not always completely that one file only belongs to one process. For instance, I already mentioned that the TinyCV library is loaded in multiple processes.
Yeah, right. So if you want to just work on one single backend, then probably you don't need to know that because you can just do what we have shown you before. If you need to go a bit further, like some people do with the console implementation, then yeah, it makes sense to understand that structure.
Yes, and the command processing is likely a part you don't want to touch. So
the command processing is the critical part that ensures the communication between os-autoinst and OpenQA. And there, of course, you need to have an understanding of both of these components. And this involves, let's say, to have some kind of API stability of this communication between the two components. Yeah.
And the command processing is, of course, also used within os-autoinst itself, because like obviously if you have multiple processes, they need to talk to each other in order to exchange information. And that is done by os-autovideo. As you can see, it's the parent process here, and it runs basically just after all the setup stuff, it basically just runs an IO loop, which passes commands around. For instance, and the command server then provides an interface to OpenQA, but the command processing is also done in os-autovideo. And by the way, your tests run in autotests. So far, you usually only did stuff within autotest if you did not work on os-autovideo or os-autoinst before.
Yeah, cool. Thank you very much for that additional details about the architecture. That can help. Okay, so with that, I would like to close the workshop. I will stop the recording. Thank you all for attending. After a 5-minute break at the full hour, I will be available for the next half an hour. So if you have further questions, if you want to try it out, if you would like to run os-autoinst test in your local environment, I'm happy to provide the support that you can also get at least to the point where which I showed you. Thank you all and goodbye.